All right, trust you did well on that quiz. Students in here seem to do fairly well. A few little things here and there that we needed to clean up, but good to know that we're ready to go for the test tomorrow. As far as the algebra side is concerned, well, let's make sure we're good on the graphing. Page 338 in your textbooks as we review for the last 15 or so minutes of class here. Number one, what type of graph uses sectors to relate each category to the whole? What kind of graph relates parts to the whole, class? Circle graph, good. And those sections are called sectors of the graph. Number two, what's the name of the key, usually a color-coded key, indicating how each category is represented on a graph? Class?
Legend.
The legend, very good. Number three, what type of graph has several categories represented on a single bar? What kind of graph? Several categories on a single bar. Ben?
A stacked bar.
Stacked bar graph, perfect. Number four, what helps to identify the height or length of each bar on a bar graph? Also helps you to identify the value along a line graph. What helps you to identify what the height or length of a bar means? Luciana?
Yeah.
The scale, very good. Number five, what percent equals the sum of all the categories on a circle graph? Joel?
100.
This isn't in the book. Class, how many degrees are in a circle graph? 360. You're not going to have to draw one on the test tomorrow. Don't worry about that. But I was just curious if we remembered. But 100% must be the sum of all the categories on a circle graph. Number six, what do you multiply by the total to find the percentage of each category in a circle graph? It's kind of a weirdly worded question. But let's suppose we had a circle graph and we knew that this sector was 14%. And we knew that there were 500 total cars or whatever. And 14% of them were electric vehicles. I don't know, okay? Well, what would I do to figure out how many actual electric vehicles? What would I need to do, Kirsten?
Turn the 14% into a decimal and multiply it by 500.
Good. Turn the percent to a decimal and multiply it by the total. So what would you multiply? You multiply the percent represented as a decimal. We're going to skip over 6, 7, 8. Skip over 7, 8, 9, 10, 11. Number 12. There we go. In a histogram, what does it mean if two consecutive bars are not touching? So wait a second, I thought in a histogram the bars are supposed to touch. They are. What if two bars aren't touching? What does that mean? We actually saw one example like this.
It isn't a histogram?
No?
The bar graph?
No?
It means that there's zero.
There's zero in that data category. In that class, there's zero. So for instance, if we had, your 60s and your 70s and your 80s and your 90s, including 100, okay? If we plugged those in like that and there was nothing in the 70s category, well, that means that everybody either made an A, a B, or an F, okay? Or if most of you around the country, A, B, or D, for that matter. But yeah, if their bars aren't touching, it just means there's nothing in that particular class. Good job. Number 13, what is the name, I just used this term, for a range of values on a histogram? What do we call the range of values represented by each bar in a histogram? Anyone? The class. The class. So each class of data. So again, if we were talking about age groups, the 0 to 18 class, your 18 to 35 class, your 35 to 50 class, different age brackets that people could be broken down into. Those are classes. Number 14, what graph is used to show change in data over a period of time, class?
Line graph.
And number 15 is kind of a review. What measure of center is most affected by an outlier?
Mean.
The mean is most affected. Number 16, what kind of bar graph we got here, class?
Bar graph.
It's bar graph.
It's a bar graph, simple bar graph, not a stacked bar graph or anything weird like that. What is the chart title here, Elaine?
Pet ownership in the United States.
There we go. Of course, we want that chart title at the top so we can know what we're talking about. How many dogs are owned as pets in the United States according to this graph? Bryson?
70.
About 70 million dogs. Now that's important. There's not 70. It's 70 million. You have to look at that axis title to realize it's talking about millions. How many cats? Oh, I would not have seen this one coming. How many cats owned as pets in the United States? Ben?
74 mil?
Right about 74 million. Do you see how it just barely doesn't touch the 75 minor grid line? So 74 million cats. How many birds are owned as pets in the United States? And while it's a lot less than the other numbers, still, that's crazy to think there's even this many. Joel? 8 million. How many horses owned as pets in the United States? Now, of course, we who live in the city, this could not be us, though Pippi Longstocking notwithstanding. But anyway, for those who remember that book as a kid. Jalen? About 5 million. There we go. Not 5, but 5. Only 5 horses. No, 5 million horses owned as pets. How many more cats than dogs? How many more pet cats than dogs? And yes, it's the crazy cat ladies who are skewing the results because they each have 100 of them. But I digress. Kirsten's over there like, I will be that crazy cat lady. Okay, Kirsten?
4 million.
About 4 million more cats owned than dogs. Because let's be honest, in the craziest dog fat family, 3 or 4 dogs, that seems like a lot of dogs when you see 3 or 4 dogs in one house. Cats? Who's to say? Anyway, how many more birds than horses? About how many more birds than horses, Griffin?
3 million.
Looks about 3 million more on the birds than the horses. Look at the next page. Got our stacked bar graph. Now this is interesting. Every stack is the same height. Why do you suppose that would be, class?
24 hours.
Every day has 24 hours. Doesn't matter what day of the week it is, they'll have 24. So of course, here it's not so much which day has more hours, but how do we spend those hours each day? So a little bit of a comparison here. Rather than making 5 different circle graphs, we make a single stacked bar graph to make the same comparison. How many hours did Darren spend at his job on Wednesday? So look at the job, which is the light blue section. Find Wednesday. How many hours on the job on Wednesday, Bryson?
8.
8 hours. On Tuesday, how many hours did he sleep? On Tuesday, how many hours did he sleep? And every minor grid line is how much, class?
1.
1. So that makes it easy to count. Jalen? On Tuesday, the green is the sleep. So I'm counting a different number there, Ben. Yeah, I've got 8 hours of sleep. Well, that sounds amazing. I would love to get 8 hours of sleep. 8 hours of sleep on Tuesday.
I know.
9 hours would be even better. What's the total amount of time spent on errands for the week? Ooh. All right, so you're going to have to figure out how many hours on errands each of the 5 days added up. How many hours spent on errands? Raise your hand when you've got it. Looks like we got 6 on Monday, 3 on Tuesday, 3 on Wednesday, 3 on Thursday, 2 on Friday. That's why there had to be so much on Monday, because he doesn't do a lot of errands on Friday. What do we got here, Joel? 17 hours on errands. Which days did Aaron spend the most time on things other than his job, his errands, and his sleep? Just doing what he wanted to do. What day did he spend the most time doing what he wanted to do? Jalen? Yeah, Tuesday and Wednesday both tied how many hours doing what he wanted on Tuesday and Wednesday?
Oh.
Just other activities. Each day there's 7 hours. 7 hours each of those days. How long was Darren awake on Monday? How long would Darren have been awake on Monday? How many waking hours? Well, in other words, what you got to figure out first, class, how many hours did he sleep and subtract that from 24. What you got, Luciana? 16 hours of being awake on Monday. And what day did Aaron do everything except for errands in 22 hours? He spent 22 hours doing everything except his errands. What day was that the case, Elaine?
Friday.
Friday. Good. Turn over to page 342. Turn over to page 342. And let's drop down to number 5 on this page. We just looked at a stacked bar graph. I want to look at a circle graph here. And they've already got all the percents filled in. Did they need to do that?
No.
No.
No, they could have left one of them empty, right? Because you would have found the missing percent by just adding them up and subtracting from 100%. What percent of the vegetables in the pantry were corn, class?
50.
Though there are those who would argue it's a starch, not a vegetable, but I'm not getting into that debate. What percent? I feel better about myself if it is a vegetable, so go corn. Number 6. What percent of vegetables were not peas? What percent of the vegetables were not peas, Joel? 90% not peas. The if the pantry held 50 jars, how many jars were of cabbage? 50 jars. How many cabbage jars must there have been? Elaine?
1 or 10.
10. How did you get that?
I did 50 times 0.2.
Good. 50 times 20% or 0.2 gave her 10.0 jars or just 10 jars. What if there were 80 jars in the pantry? How many of them were not corn? If there were 80 jars in the pantry, how many were not corn, Bryson? 40. Obviously, half of it's corn, so the other half ain't. Half of 80 is 40. Skip over to the next page, number 19. What kind of graph do we have here, class? How do we tell?
From the
Connected.
Because the bars are all touching here. And we're looking at the number of people, not at exact times, but in the 10 o'clock hour. In the 11 o'clock hour. So do you see that each hour is its own class of data? Which hour did the most people come? What's the busiest time of day, class?
2 p.m.
The 2 o'clock hour, the 2 to 3 class, if you will. The 2 p.m. to 3 p.m. class. How many people were in the store between 11 a.m. and 2 p.m.? From 11 to 2, how many people in the store? We're going to need to add a few numbers together here. Raise your hand when you've got it. Joel's got it.
51.
51. Looks like we got 13 people in the 11 o'clock hour, 21 people in the noon, 12 o'clock-ish hour, and then back to 17, it looks like, in the 1 o'clock hour, or in the 1 to 2 class. How many people were in the store between 5 p.m. and closing? How many people came after 5 p.m.? How many people after 5 p.m.? Adding some numbers together here. So we got 12, there's 11. It's 11 people from 5 to 6, 18 people from 6 to 7, 14 people from 7 to 8. It's like 7 people from 8 to closing, which I presume to be at 9 o'clock. Add them all together. How many people in the store after 5, Jalen? I think you might have a carrying error there. I got 50 people. 50 people between closing 5 and closing. How many more people at 4 than at 10, or in the 4 o'clock hour, 4 to 5 class, than the 10 o'clock hour? How many more people in the 4 to 5 class than the 10 to 11 class? Elaine?
7.
Just 7 more people. Which hours or which groups of times were there fewer than 15 people who came in the store? Which hours were fewer than 15 people in the store? There's several answers here. Kirsten?
10 a.m. to 11 a.m.
Good, the 10 to 11.
11 a.m. to noon.
Good, 11 to noon.
5 p.m. to 6 p.m.
Good, 5 to 6.
7 p.m. to 8 p.m.
7 to 8, and then of course
8 to close.
8 to close, which we presume to be 8 to 9. Number 24. What class would include a person who arrived at exactly 2 a.m.? Or 2 p.m., excuse me. It's 2 a.m. Stay out of the store at 2 a.m. That's burglars. Okay, 2 p.m. Okay, somebody walks in the store at exactly 2 p.m. Which class do they wind up in? Class?
2 p.m.
The 2 to 3. What if somebody showed up right at 7?
7 to 8.
The 7 to 8 class. What if they showed up right as it's closing time? They get kicked out of the store. No, don't come in. We're closed. Anyway, let's drop down to the last graph here. And what graph is this, class?
Broken.
A line graph, specifically a broken line graph. Looking at the broken line graph, which group of people tend to use their phones more in Greenville? Men or women?
Women.
Female, right? Other than there's 1 year where there were more male, pretty much the female stays on top of the male for the whole thing. Did the number of smartphone users ever decrease?
No.
No, not in any one group. Now, it went flatline a couple times with the guys and flatlined once with the ladies, but it never decreased. What year did we see the biggest increase in female smartphone users? Where was the biggest increase? Class?
2011.
2011 to 2012. What 2 years did the male smartphone users stay the same as the previous year? What 2 times did it flatline, class?
11, 12.
2012 to 2013, and then what was the next time it flatlined? Flatlined twice.
2014 to
2014 to 2015. So in 2013 it was the same as the year before. In 2015 it was the same as the year before. How many more female smartphone users in 2016 than 2011? How many more female smartphone users in 2016? Where's that? Than 2011. Where's that? What do we got here, Jalen? Well, 2011 was 2.5. 2016 looks like 3.8. So if we subtract 3.8 minus 2.5, anyone?
1.3.
Should be 1.3 million more smartphone users. How about for men from 2009 to 2013? Men, 09 to 13. So we're going from 1.7 to 3.2. That would be a difference of
1.5.
1.5 million more. And how many more women using smartphones in 2014 than the men? How many women using smartphones in 2014 than the men?
2.
Well, 0.2 million, right? 0.2 million should be 200,000, which there might just be that many more women. I don't know. That's just in Greenville? Something ain't right here. There can't be that many million people in Greenville. Greenville's not that big. Anyway, I digress. It's not my place to argue with them. All right. Test tomorrow. Graphing. Know your different types of graphs. Know which graph is used for what. Know your parts of the graph. A lot of terminology to study in Chapter 8. Okay, so study over Chapter 8. Chapter 11, we just took a quiz on. We should be pretty good, but no terms. There's a few terms from Chapter 11 to know, like what's a like term, what's the index, what's the radicand, what's the radical sign, some stuff like that. But should be good. No written homework tonight. Test tomorrow. Have a wonderful rest of your day.